A street counter counts the number of pairs of wheels that pass over it. A car with 2 axles registers as 2 counts. A truck with 3 axles registers as 3 counts. During a 1-hour period, a traffic counter registers 39 counts. How many cars and trucks pass over the traffic counter? List all possible solutions. So in this video, we're going to look at one of the possible ways you can solve this problem. So the first thing I'm going to do is write an equation. We have cars and trucks. I'm going to use the letters C and T. C for the number of cars that pass by, and T for the number of trucks that pass by. So those are my variables. Okay. This says that one car registers as 2 counts. So I'm going to do 2C. Every car registers as 2. And a truck registers 3 counts. So 3 for the trucks. And it looks like there were 39 counts total. So the number of counts for the cars and the number of counts for the trucks gives us a total of 39. So here is my equation. 2C plus 3T equals 39. What I would like to do is I'd like to solve this equation for one of the variables. It's going to make it a little easier for me to figure out the possible solutions. So I think what I'll do is I will let's solve for T. So to solve for T, the first thing I'm going to do is I'm going to subtract 2C from both sides of the equals, both sides of the equation. On the left, 2C minus 2C just cancels. So on the left, I just have 3T. On the right, I have 39 minus 2C. It might be tempting to do 39 minus 2 and get 37, but I can't do that because these are not like terms. I have 39, and then remember that C stands for cars. So these are two unlike terms, so that's as far as I can get as far as combining goes. The next step I'm going to take in order to isolate T is to divide every single term by 3. I want just one T, not 3 of them. So let's divide everything by 3. 3T divided by 3, the 3's just cancel, leaving me a single T, which is what I was going for. So on the right-hand side, I'm going to do 39 divided by 3. That's 13. And then negative 2C divided by 3. Negative 2 divided by 3 is negative 0.6 repeating. That's just kind of a yucky decimal. So I'm going to leave it in its fraction form. Like that. So here is my new equation. I have solved for T, and I have T equals 13 minus 2C over 3. And the reason I've done this is because it's going to make it easy for me to plug in possible values for C and calculate the corresponding values for T. So I'm going to make a table for myself. Cars, remember cars is the C, and trucks, which is T. Because T is the variable that I've isolated, I'm going to leave that column empty for now, and I'm going to fill in possibilities for cars. As far as cars on the road, obviously you can't have a negative number of cars. That makes no sense. And you can't have any decimals for cars either. So I'm just going to use whole numbers, starting with 0. I could have 0 cars on the road. Let's plug 0 in for C and see what we get. So T equals... Actually, let me write it in the table to keep it organized. Where's my undo button? There we go. So T equals 13 minus 2 times 0 over 3. I'm going to go ahead and grab my calculator and see what I get. What happens if I do 13 minus 2 times 0 divided by 3? I typed something wrong because that's not right. What did I do? Oh, no, I didn't. That's right. Sorry about that. 2 times 0 is 0, and 0 divided by 3 is still 0, so I do end up with just 13. I don't know why I thought that was wrong. Okay, so if I plug in 0 for C, I end up with 13 for T. That makes sense. I can have, it could have happened that there were 0 cars on the road and 13 trucks, so I've got my first possible solution. let's move on. And what if there is one car? Is that possible? So 13 minus 2 times 1 over 3. What will that get me? 13 minus 2 times 1 divided by 3. Oh, okay, I get a decimal. I get 12.3 repeating. 0.3 repeating is 1/3, and you are not going to see 1/3 of a truck driving along the road. One car is not a possibility because we'd have to have a fractional amount of trucks. So that is not one of the possible solutions. Let's move on though. Let's try 2 cars. What happens if I replace my C with 2? Will this work? Let's see. Go back here. There you are. So 13 minus 2 times 2 divided by 3. Nope, not going to work. We have 11.6 repeating. 0.6 repeating is 2/3. Again, 2/3 of a truck just doesn't make sense in this scenario. So 2, not a solution. So I'm going to be putting check marks where there are solutions, and I'm going to put an X where it just doesn't make sense. So we tried 2, let's try 3. Now you're probably getting the gist here. We're going to keep going until we run out of possibilities. This is, again, this is just one way that we can solve this. There are several other ways. I personally like this one for people who are starting to practice algebra, especially for the quantitative reasoning students. It gives you a lot of good practice plugging in values, which is something you're going to want later in the class, and also making sure you know how to use your calculator. So this is why I've chosen this method. You might find another method you like better, and if so, cool. All right, so if we plug in 3, hey, that one worked. I got a whole number. I got 11. So that's a possible solution. So go ahead and pause the video now and keep going. Try 4, 5, 6, see what you get. I will go ahead and speed through this part so you can see what solutions I get, but definitely pause and try it yourself. I want you to be able to practice getting answers on your own. Okay, and we're back. So you can see I've been through 20 different calculations here, and I'm going to stop here at 20 because I ended up getting a negative number. Now, if you look back at all the results that we have here, hopefully you see a pattern developing. Let me go back to the beginning. Okay, so I had 13, then that went down to 12.3 repeating. That went down to 11.6. That went down to 11, down to 10. Every time I did a calculation where the number of cars went up, the corresponding number of trucks went down. So if I were to keep doing this, I would continually get smaller and smaller values for T. And since I ended up getting a negative, I know the next, if I tried 21 cars, I would end up with another negative. 22 would be another negative. It's going to continue following that pattern where the number of trucks decreases, and it's never going to get back into a positive number. And like we said earlier, it doesn't make sense to have a negative number of trucks. So I'm stopping there. And it looks like I had 7 possible solutions. There were 7 possible things I could plug in for the number of cars that gave me a reasonable number of trucks. Again, no decimals or no negatives or anything. So, well, my pen decided to just stop working. Sorry about that. But thankfully, it's the end of the video. So looking back at my results, I had 0 cars and 13 trucks. That worked. The next solution was 3 cars and 11 trucks. That worked. We have 6 cars and 9 trucks, 9 cars and 7 trucks, 12 cars and 5 trucks, 15 cars, 3 trucks, and finally 18 cars and 1 truck. And you'll notice, hopefully anyways, that if we list out all the, oh yeah, my pen definitely stopped working. Sorry about that. If we list out just the correct answers, which I would encourage you to do, you'll find a pattern developed. For every solution, the number of cars increased by 3, and the number of trucks decreased by 2. So what I mean is we had 0 and 13. The next solution, the number of cars went up to 3, but the number of trucks went down by 2. 13 minus 2 is 11. And that happened the next time. The next solution, the number of cars went up by 3, so it was 6, and the trucks went down to 9, right? Everything's broken. There we go. 6 and 9. And then it happened again. We should have 9 and 7. So if you are working through this and you start to see the pattern developing, and yes, the pattern is directly related to the coefficients 2 and 3 from our original equation, when you see that pattern, you can go ahead and run with it. There will always be patterns that pop up in these types of equations. And if you can find it, it may make your work a little simpler. There was no harm, of course, in doing the equations, even if I had gotten to a point where I knew that I was going to be increasing by 3 and decreasing by 2, I could have theoretically skipped over the ones I knew wouldn't work, but there was no harm in doing it anyways, just to be positive. And also, if this is a written assignment for your class, usually they do like it when you have all your work written out and you can clearly explain what you did, why you did it, and how you did it. So that should be it for this one. I will include links in the description to other resources that may be useful for solving an equation with 2 unknowns. If you have any questions, please feel free to leave them in the comments.